All right, so last week, Wednesday, a week ago today, we threw the kitchen sink at you on graphing sines and cosine graphs. They're basically one and the same. Everything that we're going to talk about here in the next few days works for sine and it works for cosine. But in order to do that, in order to have everything work for you, you need to know what the basic sine and the basic cosine graphs look like. For us, okay, these are functions, and all of these functions have a domain. Oops, hit the brakes. Hit that. Have a domain of all real numbers. Okay? There is not a number that you can, or an angle, I should say, because remember the inputs are angles. There is not an angle that you can't put into sine or cosine and get out a value. Okay? So the domains for sines and cosines are all real numbers. It's the only two that the domain is all real numbers. The other four, tangent, cotangent, cosecant, secant, have restrictions. Okay, they have spots where they're either dividing by zero, I shouldn't say, they're dividing by zero, so they can't happen. Okay? So, let's start with working out the sine function. Okay? So if I input an angle, and these are all in radians, okay? So if I put in 0 into my sine function, what is the sine of 0? 0 degrees, 0 radians. Sine is what? You should know this. Like, this should be, you should have this memorized, just as an FYI. If not, you should be looking at one of the many unit circles around the room. Sine of 0. 0. Okay, so that means that the sine function goes through the origin. Okay, let's go to the next one. Pi over 6. What is the sine at pi over 6? 1/2. Next one, pi over 4. Root 2 over 2, which is approximately how much? Somebody with a calculator. Square root of 2 over 2. Approximately how much?
0.703.
703?
7.
707?
Yep.
Okay. Pi over 3. We're at 3 over 2. How much?
0.866.
866? Okay. Pi over 2. 1. Let's keep coming. 2 pi over 3. We're at 3 over 2, which is going to be our 0.866. 3 pi over 4. 5 pi over 6. Pi. 7 pi over 6. 5 pi over 4. I had to think there for a minute. Negative root 2 over 2. So that's going to be our negative 0.707. 4 pi over 3. Negative root 3 over 2. Negative 0.866. 3 pi over 2. What's next? 5 pi over 3. Uh, 7 pi over 4. Uh, 11 pi over 6. And then the next one would be 2 pi, which would bring me back to 0. Right? Okay. Right? So the sine curve is going to look like this. Now, you'll get into this and you'll be able to do this very rapidly. We'll reverse engineer the sine curve. Okay? Sine curve starts middle. So it starts at your middle line, then it goes high, middle, low, middle. So it looks like this. Okay. You're going to need to graph on this graph every single time. You are going to need to put down your 5 key points. Come on. Your key points are that one, that one, that one, that one, and that one. Okay. You are going to need to then label them. So this would be 0. My high point would be at pi over 2. Back at the middle, we're at pi. My low point would be 3 pi over 2, and my end would be at 2 pi. You are also going to need to label your vertical axes. The maximum point is 1, the middle point is 0, and the low end is -1. Okay? That is your basic sine curve, your mother sine, if you will. Okay? Now, let's talk a little bit about that. You can add this right to the bottom of yours. I will recreate. Oops, I guess I won't recreate. Come on. That's what I want. Okay, so let's talk a little bit about that sine curve. Does everybody have it written down, labeled, all that fun stuff? Okay, all right. So here are some observations that we can make based off of our sine curve. First off, the domain of our sine curve will always be all real numbers. Okay? The range, now we're talking y values. Domain was x's. We only drew first lap, okay? But that one would go on forever and ever and ever in both directions. Okay? We only drew first lap. Range, smallest that my y's get. -1, biggest that my y's get. 1. So are those included or excluded? Included, so that would be brackets. From -1 to +1. Which means that the highest that it got was +1. The lowest that it got was -1. What is the average of +1 and -1? 0. So that means my middle is 0. Okay. The middle is the average of the high and the low. Okay. The amplitude, which is what we're going to focus in on today, we're going to start tweaking that today, The amplitude is the distance middle to high or middle to low. Okay? So in this particular case, the distance from 0 to 1 is 1. From 0 to -1 is also 1. So my amplitude is also 1. Come on. Okay. The start of this, of the parent one, it starts at 0 because we go first lap, which means it ends at 2 pi. I should add here that this is a vertical distance there too. Actually, let's put it over here. Actually. Okay. Which means that my period, that is my horizontal distance start to end. So that means that my period then is 2 pi. In one of the Pirates of the Caribbean movies, it's the one where Keith Richards plays Jack Sparrow's dad. They go to like the Pirates Council or whatever. You know what I mean? And they all talked about the pieces of 8. Okay? Right? These are the pre-calculus pieces of 9. Okay? So there are 9 things that we can ask you then about any graph to go along with the graph. So if we're looking ahead to the test on the 14th of November, okay, if we're looking ahead to that, there's going to be 6 graphs on there. Okay? Each of those problems is going to be 1 point for the shape of the graph, and by shape of the graph, I mean this, okay, that you've got that going in the right spot. 1 point is going to be for your 5 horizontal labels. 1 point is going to be for your 3 vertical labels. Okay? Then we're going to ask you some side questions. And the side questions that we're going to ask you are, what's the domain? What's the range? What's the high? What's the low? What's the middle? What's the amplitude? What's the start? What's the end? What's the period? Okay? So we're going to ask you all of those on top of the graph. I shouldn't say all of them. We're not going to make you do all of them for every single one. Okay? But we can, from that pool, come up with it. Questions on sine? Okay, let's go to cosine then. Again, we're starting at 0. So what now is the cosine at 0? 1. Then we can go to pi over 6. Root 3 over 2, that's our 0.866 number. pi over 4, root 2 over 2, that's our 0.707 number, pi over 3, 1/2, pi over 2, 0, 2 pi over 3, 1/2 again, 3 pi over 4, 5 pi over 6, pi, -1 there, yep. 7 pi over 6, oops, I forgot the root. 5 pi over 4, oops, I forgot the pi there. Let's see if this works. Nope, that didn't work. What's up?
Isn't pi over 3 the root 3 over 2?
Pi over 3. No, because now we're cosine. Wait, yes, it should be. Yeah. Wait, hold on.
Yeah, this is the x side, right? So pi over 3 would be root 3 over 2.
No, this one's wrong. That one's wrong.
Okay.
Yes. Yep, just that one is wrong up here.
Okay.
Yep.
Watch out.
Careful. Careful, it's falling.
You guys act like I wasn't gonna catch it. 7 pi over 6 was my next one. 5 pi over 4. Four pi over 3. 3 pi over 2. 5 pi over 3. 7 pi over 4. 11 pi over 6. And 2 pi. Back to 1.
Your 2 pi over 3 has to have a negative in front of it.
2 pi over 3 needs a negative in front of it. Yes, it does. Yep. Okay. So cosine starts high, then it goes to middle, then it goes low, then it comes back to the middle, and then it ends at the high point. So cosine looks like that. First lap. Okay. Our important ones, that one, that one, that one, that one, and that one. Okay. So once again, this would be 0, pi over 2, pi, 3 pi over 2, and 2 pi. Vertically, it went all the way up to 1, and it went all the way down to -1. Sorry. Give you a chance to get that written down. Observations of cosine, then. Okay, so you have it on yours. Come on. Domain. It's going to be all reals. Range, that's Y's. Lowest, -1. Highest, 1. So that means my range is from -1 to positive 1. Which puts my middle at 0. Which makes my amplitude 1. Okay, so that's all the verticals. Horizontally, where did it start? 0. Where did the first lap end? 2 pi. Which makes my period then be 2 pi. Distance from start to end, 2 pi. Good. Okay. What's up?
Can you scroll back up?
How far?
That's fine. Yeah.
Try and get as many as I can on there. Good. All right, so as we talked about kitchen sink day, we're going to have different transformations to those first lap waves. Okay? And again, the domain is always going to be all real numbers. No matter what transformations happen, the domain is all real numbers. Okay? No restrictions on sine and cosine. Okay? Today, I want to focus in on this A value. This A value is going to be for the amplitude. Okay? That's going to be your vertical stretch. Okay? What the A value does is it affects, if you will, or has power over the high the low the amplitude and actually, I won't even put this one in quotes because it's not really. And the orientation. What I mean by that is, if A is negative, if A is positive, then it goes just like we just showed you. Sine, middle, high, middle, low, middle. Cosine, high, middle, low, middle, high. Okay? If it's positive, like we have been. If it's negative, then that trig function is reflected in the middle, in the line y equals the middle. For both. Okay? For both sine and for cosine. So if A value is negative, sine would start middle still, but instead of going up, it would go down to the low. Then back to the middle, then to the high, then back to the middle. If it's cosine, instead of starting up, it would start down. It would start at the low, middle, high, middle, low. Okay? So those get flipped over, reflected, if you want to say rotated around that middle line, okay? However it is, you can get it into your brain. Okay? Let's try some. Okay? Y equals 2 sine of x. Trying to get it all on one so that I don't have to scroll. There. Okay. All right. I'll do some fixing here later. Okay. Without even starting, without even graphing, what's the domain of this function? All real numbers. Always, all the time. Okay. Now, this 2 is going to be so normally the one that we just showed you, the parent function, if you will, the mother sine function, the amplitude was 1. Okay? Because there was a 1 in front of the sine. Now there's a 2, so that 1 gets multiplied by 2. So that means then that because there's nothing else here, that my middle is still going to be at 0. Because there's no d value out here. We haven't gotten to that yet. Okay. My amplitude is 2 because that's my A value. Okay? My A value is my amplitude value. So therefore, my amplitude is 2. Which means then that that's the distance from the middle to the high. So where's my high? 2. Distance middle to the low. Where's my low? -2. Okay. I'm still going to start at 0. I'm still going to end at 2 pi, which means my period is 2 pi, because we haven't gotten to tomorrow yet. Okay? This is a sine function that starts middle, high, middle, low, middle. That pattern will always stay the same. Okay? Unless it's an A, negative A. But that pattern still is the same. You just reverse it on a negative A. Okay? So, my verticalness, now it went up to 2. It went down to -2. Middle was 0. 0, start, 2 pi end. This is another way of remembering how to find those. Half of 2 pi is pi. Half of pi is pi over 2. Okay? And then the average, pi plus 2 pi is 3 pi, divided by 2 is 3 pi over 2. When we get into horizontal shifts next week, Tuesday, that halfway, average way, okay, will come in handy because you'll have to do there'll be some extra math going on. Okay? That's it. That's a completed graph. First flat, 2 sine of x. Questions? The range? Oh, we didn't fill in the range. Range would be from -2 to +2. Yep. That's just low, comma, high. Always with brackets.
Why is it always with brackets?
Because it's inclusive.
Oh, okay.
Yep.
So like if it wasn't
we can get to 2, because it would, if we would have done that chart again.
Okay, that
would
makes
have-
sense.
Yep. Good. Ooh, -3 cosine. Okay. Domain. All real numbers. Middle. 0. Yep. Okay. My amplitude. What would my amplitude be? 3, because it's a distance. Yes, it's -3 in the problem, but because it's a distance, we have to take the absolute value of it. So my amplitude here would be +3. Okay? Which means, how high does this graph go? 3. How low does this graph go? Which puts my range from -3 to +3. Start, end, and period all stay the same for now. We'll tweak that tomorrow. The negativeness now flips it over. Okay? That -3 will flip this graph. So instead of starting high, it's going to start low, middle, high, low. Horizontally, went from 0 to 2 pi. Halfway through would be pi. Halfway through would be pi over 2. Halfway through on the other side, 3 pi over 2. Low, -3. Middle, 0. Top, +3. Okay? Fractions, no big deal. It doesn't matter what your A value is. That A value is going to be your amplitude. Okay? Nothing else changes. The only thing that changes, even with fractions, is just your labels. The only thing that is ever going to change on any of these is the positioning of those numbers. Okay? Or what those numbers are in their positioning. Okay? So this is a cosine curve with a positive A value. I could automatically, and you should be able to, even after 3 cosine graphs, or this being your 3rd cosine graph, you should be able to know starts on high, goes to the low, ends on high. Okay? And then the only thing that you have to fill in now is oops, missed it. With me? Memorize the pattern. Okay? Because the pattern's never going to change. Okay? Only thing that changes is the numbers, and you get that from the equation. Okay? Try that one on your own. Here's all real numbers. My amplitude is 3/2. My middle is still 0, which means we go up to 3/2. We go down to negative 3/2. Sine curve with a caution. Oops, not a caution. Okay. So that means that's going to be flipped over. We went up to 3/2. We went down to negative 3/2. We got that. Questions on that one? Good? Okay. All right, one last thing, and it's a super duper quick thing. Super easy. Okay, I shouldn't say super easy. Relatively stress-free. Okay? And that is the D value on the end. Okay? That D value on the end is your vertical shift. Amplitude is your vertical stretch. D value on the end is your vertical shift. It is in control of the middle. Okay? The D controls your middle. And that's it. Everything else gets adjusted because of that, but it's only in control of the middle. Okay? Let's try one. Cosine of x plus 10 or 10 plus cosine of x can be written either way. The reason that we show them to you in both ways is this is the first one is kind of Wausau West way. We'll go right. And for some reason we found over the years, this is how NTC likes to put it on your finals. Okay? They mean exactly the same thing. Okay? But we bring that up to your attention that those mean the exact same thing. Okay? So, with that being said, now I'm going to look at this number here and straight up as is 10 or positive 10 is my middle. I look back here. This is my A value. What is there? 1. That's my amplitude of 1. So now, distance from my middle to my high is my amplitude. Okay? So where would my high now be? It would be at 11. Where would my low now be? Be at 9. Which means my range then is now from 9 to 11. Those green ones we'll get to tomorrow. Okay? Now, on your graph, notice how we put the horizontal axes way down here at the bottom. Because my cosine curve is now going to be up here. So my horizontal axes shouldn't be in the middle now. Because now we went from 9, 10, and 11. If you want to draw in a dashed line for your middle, that's fine. I have no problem with that. It just can't be solid because a solid line would be an axis. And that's not where the x-axis would go in this particular problem. Okay? Questions on that one? Good. So again, this homework packet will be due on the 14th, which is in 2 weeks. And you will probably have a formative this week, Friday, instead of practice, just as an FYI. Okay?
With the Friday that was going to be a formative be practice then?
No, the Friday that was going to be a formative is going to be a formative. I know.